Hey everyone, it's Bradley Bush with an algebra video. Today we're discussing systems of linear equations in three variables. If we're dealing with linear equations and we have three variables, then that means we are in three space. So we can see our beautiful 3D plot over here on the right to remind us. Let's talk about our to-do list for today. So first of all, we have a quick overview of systems of linear equations, what they are, what they look like. Then we have three different types of problems that we'll see when we deal with linear equations in three variables, and we'll discuss the two solution techniques that we'll need to solve them. So let's start with our overview. So what exactly is a system of linear equations? Because it sounds kind of complicated, but lucky for you, the truth is it really isn't complicated at all. It's actually pretty straightforward. So let's start at, I think, the easiest part of these, the three variables. They say in three variables, but really all that means is that you have three variables in your equations. And usually we deal with x, y, and z's. But they can be any three variables, and they don't necessarily need to be x, y, and z. But in three variables, that just means we've got three variables in our equation. That's it. How about the word system? What does that mean? Well, it means we have more than one equation in our set of equations. And since we are dealing with three space here, and we've got three variables, that means each of our equations is a plane. So we've got more than one plane. In fact, we generally have three of them in this section. So we'll have three planes in three space. So those three equations or three planes represent our system. So system just means more than one equation. And the last piece, which we've kind of already discussed, linear equations. That means we have equations that look kind of like this. Ax plus by plus cz equals some constant d. So x, y, and z are the variables, and a, b, c, d are constants. So it's just a plane. It's a flat 2D surface in three space. So that's it. Not too bad. Let's look at an example here. So this is an example system. We have three equations. I've numbered them 1, 2, 3. Each of them has three variables. There you go. It's not too bad. And people will ask the question, what does a solution of this system look like? Well, the answer is it's any point, which since we're in three space, you'll have an ordered triplet, x, y, z. So any point in the three space that's on all three of these planes at the same time. That is a solution. Sometimes you've got a lot of them. Sometimes you just have one. And you can verify that a point is a solution to the system by plugging that x, y, z into all of the variables. So you pick an equation, 1, 2, or 3. You plug in that x, y, and z into the x, y, and z in the equation. And if you get a true statement, like 3 equals 3, then you know that that point is on that specific plane. And then you repeat the process for the other two equations. And if all of them give you true statements once you plug in the x, y, and z, then you know that this point is on all three planes at the same time and is therefore a solution to the system of linear equations in three variables. So really, you're just plug and chugging there. It's nothing too crazy. So we have three possible solution options or categories when we're dealing with systems of linear equations in three variables. And there aren't any others. So if you can just remember these three, you should be good to go. Option number 1 is one solution. So in other words, you have an x, y, z point that's on all three at the same time. So that yellow dot is on all three of those planes. You see a blue plane, purple plane, and a red plane. Same down here below. We've got three separate planes, and there's only one spot, which is the yellow dot, where they all touch. So that point, that XYZ point, is the solution to those equations. So if you're going along and you get an answer, an XYZ coordinate or triplet, then you're in this situation. That's your point right there. Option number 2, there is no solution. And there would be no solution if all three of these planes do not touch simultaneously ever. So those planes could be all parallel and not touching, as you see here in the top picture. All three of those planes are parallel, not touching. Or you could have, as in this second picture, you could have touching going on, but not all three of them at the same time ever. So in this picture, you have the red and the purple are parallel, and the green touches both of them because it crosses, but all three of them aren't touching at the same time ever. If we go down a little bit further, we see another example where all three planes are touching sometime again, but again, you can see in the middle here, there's a spot, there's openness, so it looks kind of like an A, a capital A, and not all three of them are touching at the same time. So you can have a lot of different options for no solution, but you'll see a no solution. And when you have a no solution, the variables will drop out, and you'll get a statement that's false, like 0 equals 5. It's not a true statement. So you know that you are in the no solution category when that happens. Third category, infinite number of solutions. So you can see here on the right, you have the three planes that are all touching in a line. That line is infinite, and you can see all the little dots on the line. All of those points are x, y, z coordinates that are touching all three planes at the same time, and they make up a line, a vertical line. So you have an infinite number of solutions. If you're in this category, you're going through your problem, and the variables will drop out again, and you'll get a true statement, like 0 equals 0 or 5 equals 5. You know that you are here in the third option. So again, we only have 3 options for solution categories: one solution, no solutions, or infinite solutions. So again, how do I know which option I'm in for a given system? So to summarize what we just discussed, if you get an answer, an XYZ coordinate, you're in option 1. That means you've only got one option. Unless you did the problem incorrectly, of course, and made a mistake somewhere in your algebra. But as long as your algebra is correct, if you go through and get an answer, you're in option number 1. That answer is your only answer. If you go through and your variables drop out, they'll cancel out somehow as you're doing your algebra, then you know you're in option 2 or 3. If what is left is a true statement, like 0 equals 0, 2 equals 2, then you know that you are in option 3, which is the infinite solution category. If what you get is a false statement, when the variables drop out, like 0 equals 2 is not a true mathematical statement, then you know you're in option 2, which is no solution. Not too bad, huh? So you might also ask, how do you solve these systems of linear equations in 3 variables? Well, here's a quick outline for you. You'll have 3 equations. They'll be numbered. I number them in my problems, at least, and I think it's a good idea if you do it too, because then you can identify them quickly. So we'll choose 2 of those 3 equations and use the substitution or addition method to eliminate one of the 3 variables. If you aren't familiar with the substitution or addition method, then you should watch my videos on linear equations in two variables, because those are the two methods that are used to solve linear equations with just two variables. So solving linear equations with three variables is just one extra step. So we'll take two of the three equations, and we use substitution or elimination to get rid of one of the variables. We take that new equation that we just found, and we put it aside. Then we go back and we repeat the process, but we choose two different equations from our three equations and eliminate that same variable, the one that we eliminated the first time. That'll give us another equation, which we take and put with our first equation that we found, and that gives us two equations with two variables. And once we have two new equations with two variables, we're just back to a previous section where you just use the substitution or addition method to solve for the two remaining variables. Once you find those two remaining variables, then you take those two variables, plug them back into any of the three initial variable equations you have, and solve for that last variable that you are missing. It's a lot to say in a paragraph, but once you do it, it's really not that bad. That's it. If you guys have any questions, check out my other videos. I've got a video on each of the categories. So no solution, one solution, and infinite solution. And then I also have an additional video on what happens if you're missing a variable in one of your equations. So check out those videos. If you have any questions, let me know.